Okay, so in 4.6 we dealt with fractional coefficients where we just had to like multiply by something to get rid of all the fractions where like a fraction was stuck to each x. Well, now it's a little bit different because we've got fractions all the way through and they're kind of built into each of these. We can't just multiply by a single number to get rid of them. So this is where we've got variables in the denominator. Like we didn't really have to deal with that before. We were just multiplying by numbers to get rid of them. And these are fractional equations. So what we've got are equations that have fractions in them, and our whole goal is to get rid of them each time. So one of the things that we're going to do is that at the end, and this is the most annoying part, this is the point that you're going to hate, is once we come up with our solutions, we do have to check them all by plugging them back into the original, because when we start multiplying by a whole bunch of things there, it starts to introduce some new situations in there that may or may not lead to the correct answer, so we have to check our answers at the end. We're going to come up with a bunch of answers. Some of them may not be legitimate answers that we're going to have to check. So what we've got here are three things that we are going to try to make. Now it's ugly because there's a whole bunch of fractions there and we all want to get rid of it for those of you who are doing other things right now. So basically what we've got is three fractions, because if you think of the number 2, it's a fraction as well, right? It's 2 over 1. So when we did this before, to get rid of the fractions, what we had to do was multiply by whatever they all go into. We need something that they all go into. So this one has an x minus 5. Sorry, this one has an x minus 5. This one here can be factored. So let's see what all these, let's just break these down into the simplest forms. Let's figure out what this would equal if I factored it. X minus 5 and x minus 2. So if we took that and if we took that polynomial there and factored it, what we would have is x minus 5 and x minus 2. I'm just going to rewrite that so it looks a little easier here. It doesn't get confusing. We've got x minus 5, x minus 2, plus 2 over 1 is equal to x minus 4 over x minus 5. Notice that in the denominators, here are the things that we've got. We've got an x minus 5. That's here as well. We've got an x minus 2, and we've got a 1. So we need to make sure that to get rid of these fractions, that we use one of each of those. That we're going to use an x minus 5, an x minus 2, and 1. Well, 1's not going to change anything. If we multiply by 1, that's not really going to matter there. So we're going to multiply everything by x minus 5 and x minus 2. Because this one already has an x minus 5 over here on the right. So we're going to multiply the tops of these by x minus 5, x minus 2. And I'll show you why we do this here in just 1 second. X minus 5, x minus 2. We're going to multiply this first thing by that. We're going to multiply the second thing by x minus 5, x minus 2. And then we're going to multiply the last thing by x minus 5, x minus 2. And the hope is that in doing this, that we no longer have fractions. So watch what happens to the first term here. We're going to look at the first term. And when we look at this very first term here, what's going to happen with the x minus 5s and the x minus 2s? They're going to cancel. This one cancels with this. This one cancels with this. And all that's left over for the first term is just 3. Now, for the second one, is anything going to cancel? No. Here, nothing on top is going to cancel out with the things on bottom. So we've got 2 times x minus 5 times x minus 2. So we've got 3 plus 2 times x minus 5, x minus 2. Is equal to, now this last one here, is anything going to cancel out? The x minus 5 will cancel out, which just leaves us an x minus 4 times x minus 2 on top. Now, let's work some of these out. Actually, I already know what this equals. How do I know very quickly what that equals? We had it all the way back here. Remember back here, that's how we got the x minus 5, x minus 2. So I'm going to make my math a little bit easier by just doing this. It's 2 times x squared minus 7x plus 10 is equal to x minus 4 times x minus 2. All right, let's do a little distributing here. We get 3 plus, somebody hook me up with this distributing here. 2x squared minus 14x plus 20 is equal to, now we have to work this one out as well. How do I do that? Sorry, it's a little delayed there. Let me see if I can make it a little faster. There we go. How do I do that one? We're going to FOIL it. What's the first term times the first term? X squared. Sorry, it's delaying here a bit. There we go. First term times first term is x squared. X times x is x squared. Outer times outer? Okay, so that's the inner term, but that's all right. We can do that one first. Okay, now outer? Minus 2x. And then last times last? Plus 8. The good news is we have a whole lot of stuff, and this is a little bit easier to deal with. Let's simplify the left side, combine anything we can on the left, combine anything we can on the right, and then move it all together. So, is there anything on the left-hand side that can be combined? Okay, the 3 and the 20. So we get 2x squared minus 14x plus 23 is equal to, what about the right-hand side? What is this, sorry? Minus 6x plus 8. Now we need to get everything on the same side. How should we do that? Yes, sir.
Wouldn't you subtract the right?
Yeah, let's subtract the stuff on the right and move it to the left. Sorry, there's a delay here. I'm not sure why it's... All right, let's try subtract x squared and subtract x squared. Anything else that we can subtract? So here we go. We're at x squared minus 14x plus 23.
Please send Andrew NTN down to Student Services.
He's on his way.
Thank you.
Anything else that I can subtract? Or I can add. Add 6x, add 6x. What are we at now? Subtract 8 and subtract 8. We have to be careful with that right-hand side because a lot of people are ignoring this and then they forget what to do. 8 minus 8 is equal to 0. 23 minus 8 is 15. So we get x squared minus 8x plus 15 equals 0. Now, I'm supposed to solve this. How do I solve that? Let's factor it. Two things that multiply to give me 15 that add to equal negative 8. Negative 5 and negative 3. How do I solve this? Set each one of them equal to 0. X minus 5 is equal to 0. And x minus 3 is equal to 0. The first one becomes x equals 5. The second one becomes x equals 3. Okay, now we would be done except for the fact that we have to check these. Often we get extraneous solutions, ones that are not going to work out for us, that because we're like, oh, these answers will not check out. Definitely one of these answers doesn't look. Take a look. Let's go back for a second. One of these answers is definitely not going to work. Our answers are 5 and 3. Take a look at that equation right there. Which one is not going to work? What are which answers will not work? What are the ones that we don't like? Like we said, x cannot equal. What can x not equal? Out of like our two choices here, 5 and 3, which one can it not equal?
Oh, it can't equal 5.
Why?
Because then it would be 0.
Because we can't use 5 because it would make this denominator equal 0. Now, I'm going to tell you right now, you've got two options. You can go back and look for those two places and go, oh, okay, well, it's not going to work out there. That is not going to work out. It's when we plug it in, it's not going to work out there. So 5 is not going to be an option. X cannot equal 5. Or if you want, you can plug in each number and go through every single one there. So will 3 work based on this?
Yeah.
Okay, so we're okay with that one. And so we've got X of these two answers. We know that X cannot equal 5, but it can equal 3. So we had to check these. We checked that one. There was no problem there, but we checked this one, and there was a problem there when we went up and checked it. So how would you write your answer? You would write it as just X equals 3.
But we need to say that X doesn't equal 5.
You can add it on there. I mean, it shows that you checked it. Even if you made a mistake then, if you went up and checked it, I can at least see there and go, okay, I can give you some points for that. Give everybody a minute to catch up there. Okay, let's go on to B right next door. Okay, so we have variables in the denominator, and that makes these things stink. They're hard to work with. So to get rid of them, we're going to look at the denominators, and I see an x minus 1 and an x minus 3. So I need to multiply both of these by x minus 1 and x minus 3. So this one over here is going to be, the first one is going to be multiplied by x minus 1 and x minus 3. That's times the x over x minus 1. And the one on the right, this x minus 2 over x minus 3, will also be multiplied by x minus 1, x minus 3. Whole point of this is to get rid of what's in the denominator. And this is how we do that. Now, what gets left over, we're going to have to check that. All right. So what can I do now that I'm here? Cancel out what? Good. X minus 1 cancels out with x minus 1. Is there anything else that's going to cancel out? X minus 3 and x minus 3. So on the left, we have to multiply x times x minus 3. And on the right, we have to do x minus 2 times x minus 1. So let's start here on the left. What is that going to give me? X squared minus 3x. Now let's do the right. Now on the right, we're going to have to FOIL this out. First term times first term, outer times outer, inner times inner, last times last. What should I multiply first? X times x gives me? X squared. The outer terms, minus x, or negative 1x minus x, same thing. Inner terms, negative 2x. And then finally the last terms, plus 2. All right, talk to me about what to do from here.
You combine the negative x and negative 2x with negative 3x.
Okay, so we get negative 3x plus 2x squared. Okay, what's up next? Let's subtract x squared from both sides. And now we're at negative 3x is equal to negative 3x plus 2. Add 3x, that becomes 0. Add 3x, that becomes 0 plus 2. And we get 0 is equal to 2. What does that tell me? Because that's a very bizarre answer. But that happens the same way in Algebra 1 that it happened. It's the same thing when this happens.
Doesn't work.
No solution. If it gets to something that's just simply not true, 0 is equal to 2 is not true, that does not check out. It is no solution. Okay, so let's go on to the next page. This is C. All right. I don't really know what this is over here just yet. I don't know what to multiply by until I break that down. So let's start by breaking that down. Let's factor it. C minus 2. What else? z plus 3. Okay, so we've got a z plus 3, we've got a z minus 2. Those are all the things that are in the denominator. So everything needs to be multiplied by z minus 2 and z plus 3. So we're going to have z minus 2 times z minus 3, z plus 3 times the first term. Then we're going to do the same thing for the second thing. We've got z minus 2, z plus 3 times the second term. And then finally, z minus 2, z plus 3 times the final term, which was z minus 2, z plus 3. So it looks like a lot, but the good news is that a lot of this ends up canceling out. Let's start on the first term. Anything cancel? That's z minus 2 and z minus 2. Good. Okay, so what we're going to be left with after that is z plus 3 times z minus whatever is next here. What about this next one? The z plus 3 cancels with the z plus 3, leaving just z minus 2 times 1 is equal to whatever is over here. Anything cancel out over here? The z minus 2 cancels out with z minus 2, and z plus 3 cancels out with z plus 3, leaving just 10 over there. So it becomes much easier once we cancel things out. All right, let's start on the left-hand side there. We've got z plus 3 times z. Remember, that's distributing there. What do we get? Minus 1 times z minus 2? Okay, so we get minus z minus 2. We have to be careful here because we are subtracting everything there, so we have to be very careful with this. I'll come back to that in just a second. That's going to be a very tricky area, is equal to 10. So, talk to me about that gray highlighted area. Yes, sir.
Don't you want to distribute the negative?
Yep, that negative, when we are subtracting everything in there, needs to be distributed. So that becomes minus z and plus 2. And we still have a z squared plus 3z. Anything that we can combine? Okay, so 3z and negative z become? Okay, 2z plus 2 is equal to 10. Anything else we can do?
Subtract the 10 to the other side.
Okay, subtract 10 and subtract 10. 2 minus 10 is?
Negative 8.
So we get z squared plus 2z minus 8 equals 0.
Would be z minus 2 and z plus 4.
So negative 2 times positive 4 is negative 8, and negative 2 plus positive 4 is positive 2. So this checks out. What do I do with these things now?
Go up to 0.
Okay, z minus 2 equals 0, and z plus 4 equals 0. So z is equal to 2, and z is equal to negative 4. So I'm going to go and just check real quick to see if that causes any problems back here. So we've got 2 and negative 4. Yes, sir?
2.
2 is going to be an issue. We can tell right here right there, if I put it in right there, I'm automatically messed up from the beginning. That 2 is going to be a problem. That's an extraneous solution, so I'm just going to say that it cannot equal 2. I have to change that. It can't be equal to 2. It cannot equal 2. So I came up with 2 solutions. One of them will make it undefined. Yes, ma'am?
So only one is undefined?
It may not be that any of them, it may turn out that all of them are okay. It may turn out that none of them are okay. You got to check them right there. And so that's why we went back up to see if 2 or -4 were a problem.
But you automatically know -4 is correct?
Well, one thing that we could do is, let's say you're iffy about it, is we can check -4. So we know 2 won't work. But if you're like, well, I don't know about -4, one of the things you can do is plug it in. We're saying z is equal to -4. So we could check it as -4 over -4 minus 2. All I'm doing right now is plugging it in every time I see a z up here. So I'm just going to check it right here to see if it works out. Minus 1 over -4 plus 3 is equal to 10 over -4 squared plus -4 minus 6. So we're going to check it right now just to be sure. So this becomes -4 over -6, which is positive 2/3. And minus, let's see, we've got 1 over -1, which becomes, that's the same thing right here as -1. So we get 2/3 minus -1. Anything I can do with those 2 minuses? That's going to become a positive. So we're just going to check this still. Is equal to, let's go back over here, 10 over, -4 squared is 16. Plus -4 minus 6. What does that denominator become? 2/3 plus 1 is equal to 10 over 6. Can that fraction be reduced? To what? 5 over 3. So we get 2/3 plus 1 is equal to 5/3. What should I do now? Okay, we could subtract 5/3. We get, I would actually suggest for a moment that it might be easier to do it the other way. You have a question? Watch what happens when we do it the other way. Subtract 2/3, subtract 2/3 so that we don't end up in some negatives here. What is 5/3 minus 2/3? Did we end up at a true statement? Yeah, so this one did check out. It was fine. But it was just a way of us verifying what we had was true. It was going, oh, yeah, that one is definitely not a problem.
Could you have, since there was a 1 there, could you have made that 3 over 3 and just went down?
On the, yeah, change 1 into 3 over 3 and just added them there and say 2/3 plus 3/3 is 5/3? Yeah, you could do that too. All right, so we're going to stop there and we'll pick up the last 2 examples tomorrow. We split it up over 2 days. Remember that Thursday is your 4, what lessons? 4, 3, 4, 5, 4, 6, and 4, 7? Yeah, okay. My brain's a little off after the vacation.